so I would like to ask Noah and Jody to come up, right? This one is particularly close to me for a couple of reasons, right? First, Noah was my summer student last summer, right? Second, these are the two of you that were here at NDSU, right? The remainder of you stayed at UND, so I didn't get to spend as much time with you, right? I did spend plenty of time with them. And the dad works in the program, right, in nature, and you saw him earlier, Jody DeLong is right there, probably like exploding with pride every second as this is gonna go on, right? So, to go forward, go down, to go back. So, like you're gonna need it. So, we're gonna go first. Please introduce yourselves.
I'm Noah DeLong, and I'm Jody. Well, this is kind of hard to explain, so we'll try our best to make it make sense. But because we did a lot of stuff over these 2 weeks.
You're standing right in front of the projector.
Oh, my fault. I'll try my best to make it make sense. So will you? So let's get into it, guys. Oh, there's the intro. Oops. Okay, hold on. I have a. So we'll just try to go step by step on what we did because it was really a lot for 2 weeks. So what we did was plasmid isolation, and plasmids are they're in bacteria, and it's a small part of DNA that can replicate itself in bacteria. So, but we isolated that with these little mini prep kits. That's this thing right here. And so we were able to take the plasmids out and put it. That's what plasmid transformation is, just putting it into a new bacteria. And the reason we had to put it into new bacteria is because bacteria, Dr. Vedder explained, they're like dog breeds, and they all have their own purposes. So putting it into a new one would be making it do like something else. Here, you wanna go? Hold that thing.
So this is culture expansion, which is just making more bacteria. And this is, and what we did after was harvesting a cell, which we centrifuged it, which is just spinning it really fast. And then we took our small cell pellet, which is after you centrifuge it, all of the cell pellets go to the bottom of the tube. And we put it in a smaller container, frozen.
Yeah, that's them. That's them. This is. I don't think it's them being frozen, but it's just the best picture I had to show. So this right here is just analyzing our plasmids because we put them in this thing. It's like a gel thing. I don't know how to explain it. It's really complicated, but we put them in this gel thing, and we got that gel thing from this gel thing, and then you throw it on that UV table, and you get this, and all those. Yeah, that's what I'm saying. But all these lines are plasmids, and the big thick ones are the ones that I think we're looking for. So this is just I'm trying to make it make sense here. How would you put this? This is really hard to explain. I'm trying to think of it, so sorry about the big pause. I'm sorry about this. I'm trying to remember. It's very complicated stuff. Yeah, I guess. It's basically just this stuff again. Is what I remember.
Just putting our plasmids and
Yeah.
stuff.
You remember how you used to make this situation?
Yeah, I remember that, but I'm trying to. I don't know how to explain it. You know, it's hard. But okay. So after this, we put it in this thing. It's like this big thing, and you shine like electricity through kind of, and you get these things right here. And that is the proteins that we wanted, which is the rage proteins, I believe. And that's 89, those are expressed on C, and that's the luminescence imagery. That's what we got right there. And then here you get the
So his tag protein isolation, that is basically just a way of like isolating protein. Really self-explanatory. Yeah, the one that we wanted is the protein that we wanted, and this is what we spent our time working together.
The protein that we wanted was the rage one, by the way. I forgot to mention that, but that protein is really important because. Okay. So we were just able to do all this stuff. See, this is the rage one right there. Purification of 8 and 15. That was because we had 15 samples, and we were able to get the 8th one and the 15th one purified. And the rage protein is it's important because it can develop antibodies to fight against diabetes and cancer, which I know a lot of natives get, diabetes. So here's significant to it. See? This is basically what I just said. Here's the acknowledgements. Oh, apparently we're the only people in the world, us three, Dr. Vedder, to get this so far, which is kind of crazy to me. But I didn't know that till just like 10 minutes ago. Then the acknowledgements. Our dad, obviously, because that's my dad. He's the reason we're here. Dr. Stefan Vedder for helping us for those 2 weeks, or I guess we can have to making it make sense for us. John Carlos Martinez Lopez. Where did you see that? I don't know where he is. Oh, right there. It's pretty cool. Sheridan, because she's also very nice. And then our 3 chaperones, basically, Vivian, and Kathy. And I forgot to put them, but Ismail too, from when we were in UND. Those were, they were very nice people. That's about it.
Hold on to it to see. Who's got some questions for Nora and Jody?
So either of you, did you enjoy the techniques and the bench work you were doing?
Yeah, it was a lot of.
Yeah, it was pretty interesting. I liked working with Dr. Vedder. He's a very nice guy.
Did he let you balance the centrifuge and run it?
Yeah, we actually got to do it ourselves. The big ones and the small ones, we got to balance it and then have it spin. And then we made our own shell. We made our own aggro shell as well, and put it in the cast and everything, and got the pipette in there.
So I got a good couple lab tech potentials
If it pays well.
So I have a question. One thing that tell me, or what you picked this project for a reason, right? What attracted you to the project? Do you have any sort of
Cancer runs in our family, I'm pretty sure. So that's obviously that would get close to home. And then David is also known to get diabetes, so I chose that.
Thank you. Any more questions? All right.